Howdy, this is Bob from Bob's EV Garage on my actual bench today in the shed, and we're going to be having a look at this DC to DC charger which is made for solar panels. So what I'm going to do, we've got our wiring here. This cable is to the battery and these cables are to the alternator and solar power. We're going to push those off to the side and we will start with this faceplate here. So all I'm going to do is just undo these screws and I'll come back. Now we can start to take it apart. So I have a feeling it's just a clamshell kind of design, but I'm not sure how it actually comes apart yet. Because it looks like it's got to slide out, but I'm not sure how. Maybe we have to bend this. Whoop. Something just came off. Did I done goof? I might have. Pull this way. There we go. Okay. And she's apart. We're going to have to put a little bit of work into actually getting all of these different wires and stuff sorted out so that I can show you guys what's in here. Okay. And it's open. So, what we see here is a series of transistors. And on this side, I think we've got a series of diodes. And some other transistors here. So this serves two functions. It'll have two DC to DC converters in here, I imagine. One will look after taking power from the alternator and sending it to the batteries, and the other one will take power from the solar panels and convert it into battery power. Now, the key difference between those, one is it just takes the voltage straight from the alternator. It doesn't really care what the voltage is as long as it's, 13, 14 volts, and it will convert it to a constant current that can be used to charge the secondary battery. So, by the way, this is for a dual battery system, so you've got a starting battery and a deep cycle. This is to charge the deep cycle battery. But the solar charging system will use a computer controlled program, so it will actively seek the most efficient way to draw power from the solar panel. That's called MPPT, or maximum power point tracking. And that's a really cool thing. And I'm hoping that this might still work actually, so that I can apply it to my shed or something, make something cool out of it. But let's take off these and let's have a close look at the circuit board. Awesome. So here we have the circuit board freed. It's still attached to this side because these wires are permanently soldered, but that's okay. We'll just have a look at it from here. And wow, there is a lot of stuff going on here. But let's break it down into portions. We can have a chat about what it does. Obviously, I'm not a trained electrician or an electrical engineer yet, so don't take what I say for granted. If you are really curious about something, fact check it online, but I'll do my best to be as informed as I can on this. And I should also note, there is a circuit board up here. On it, I'm seeing an alarm of some type, a trimming potentiometer. I'm not sure the function of it. I can have a look, but I imagine it's to do with the charging voltage or something like that, just some indicator. But yeah, okay, let's get rid of this and let's get on to the good stuff. Okay, first of all, let's talk about the layout of the circuit board. Whew. So, we've got our voltage out to the battery, and that's on the red. We've got our solar positive just there, so we know that this area is for the solar charging part. And over here, we've got our alternator input and our alternator negative input. So you can see the diodes there. That's to protect. If you wire this backwards, what these do, these diodes will actually allow a lot of current to flow, and it will pop the fuse because there was a fuse in the wiring loom, and that'll just, it's meant to protect the device, but honestly it doesn't really. It just pops the fuse, and something on here is probably going to get damaged anyway. So there you go. So having a look here, yeah, voltage in, that goes on the underside to this area here, this trace, which goes to these MOSFETs via a current shunt there, which is just a low value resistor that the computer uses to read the amount of current flowing into the device. On this side we have IRF3205 transistors, and we have 4 of those. Actually, I was wrong. We have 6 of those. And yeah, cool. So these 3 here are connected to one tap on the transformer, it looks like. Is that right? Yeah, okay. So we can see here, this is a center tapped transformer. So these sets of 3 transistors alternatively pull the center winding of the transformer down to ground, and that's what it uses to do the DC to DC conversion. So it's a push-pull converter, I think that's what it's called. And then on the output, this is where you actually get the voltage out to go to your charging. So there you go, and obviously that makes sense because we've got AC coming out of the transformer, which goes into these diodes here, and they are TO220 packages, so this, you know, this sort of size, and they do have a diode marking on there. Let me see if I can show you. Honestly, I think it's going to be hard to show you, but you'll just take my word for it. I'll read out the part number. They are MBR3080F, if you need that. And yeah, on the underside, we've got those diodes, and they connect to the transformer as well. And from there, I'm losing these insulating things. So less and less hope that I'm ever going to put this back together. But if I do, I'll make a video about it. So we got those capacitors there. When the voltage comes out of the transformer through the diodes, it goes over here to our voltage output, which makes sense because this is our DC to DC converter for the alternator. Similarly, we've got 2 transistors here, which, when I look, are connected to this big toroidal inductor. And what that does is it forms a DC to DC converter as well, except that this will have some sort of microprocessor, which I imagine is this circuitry here. I'll give you a better close-up of that. Whoa, check it out. Yeah, so that is coupled to this transformer, or this inductor. And what that's doing is it forms the DC to DC converter for the solar charger. And you've got your controller here, which does the MPPT power tracking. So that makes sense. Just looking over it. Anything else of worth mentioning? So the diode for the solar tracker is a MBR4060, and the MOSFET is a IRF3205. So they've used quality components here. This looks like they're all international rectifier except for the diodes. I'm not sure what company they're made by, but this looks like a decently designed circuit board. The only thing I'm noticing is that it looks like this trace here. Ooh, can I get a good image of it? Yeah, just here. It looks like it's gotten quite hot, so there is some discoloration of the insulation on the circuit board when you compare it to the other side. And I imagine that's probably because this current shunt was poorly soldered. Yeah, see, the soldering looks kind of like it had a poor connection there. You can look between the two here. You can see this one looks like it may have been not soldered properly from the factory, and that's caused that heating there. I wonder if it's damaged the MOSFETs. Yeah, I'm not looking to do too much of a diagnosis on this one. I just wanted to take it apart because I was curious about it. But there you go. I'm going to include some nice high definition images in the description so you can have a look. And yeah, thanks for watching, guys. If I do anything with this, I'll keep you posted so that we can work on this stuff together. Take it easy. Bless ya. Just before I go, for anyone who's curious about what these potentiometers do on the board, I'm just going to take a guess and say, by looking at the markings, that this potentiometer here, with the 16 volt marking, controls the maximum voltage of the battery, or it controls the maximum allowed input voltage from the alternator. And vice versa, this one here, which says 13 volt next to it, I imagine this one controls the minimum voltage accepted for the charging to occur, or it controls like the voltage of the charging or whatever for the secondary battery. This one over here with the 20 amp marking, I imagine this is allowed, like it determines the current flow that this unit allows to occur at any time. Yeah, also, something else of note, there is a temperature sensor on the board, but this wasn't really attached to anything, so I don't think this actually would work unless this was overheating for a considerable amount of time, so the air inside the unit was also hot. Maybe then it would work, but if this isn't attached to the heatsink, then it's not going to work in time to protect the control devices from a explosion if there's too much current flowing or if it's been operated at high temperature and environment. Yeah, okay, it's really the end this time, guys. Bye bye, take it easy, I'll catch you later.